Next up, we're going to be looking at the E1 reaction. This will commonly occur alongside the SN1 reaction, and they do follow very similar mechanisms. The first step is actually going to be exactly the same. We're going to have a leaving group that leaves. We need to go over some specifics about the E1 mechanism reaction first. Just like we did with the E2, there are certain barriers for the E1, and the E1 has more barriers. It's not as easy to occur. First off, our substrate. We need tertiary substituted or secondary substituted. Those are both okay. Tertiary is great, secondary is, I'll take it. Primary, not going to happen, okay? For a base, a weak base is okay. Weak bases are pretty common. Basically anything that could take up an extra hydrogen, all right, I guess so. So things like methanol or ethanol or alcohols that normally, like they wouldn't, but in this case, sure. There's going to be a hydrogen that is just trying to detach from this, is just looking for a place to go. It's just looking for a home. So something like methanol that would normally be perfectly stable and would not take up an extra hydrogen would be able to. A methanol or an ethanol or some kind of alcohol could act as a weak base. So when we say weak bases are okay, we mean like basically anything that'll take up a hydrogen is going to work. So next, we have solvent. For this to work, we need a protic solvent. We need some hydrogen binding to keep things orderly. We need that extra stability that's going to come from that intermolecular force. Next, we have no stereochemistry requirements. Where the E2 had a very specific requirement, there are none for the E1. And finally, the rate law. The rate law is going to be first order overall. Just like in the SN1 reaction, the E1 reaction is going to be fully dependent on this substrate doing its thing first, getting rid of its leaving group. Everything else happens very quickly after that, but everything's waiting on this carbon saying goodbye to this chlorine. It's like a son shipping off to the Navy. As soon as he gets on the truck, they're going to the base, and everything's going to happen very quickly after that, but his mother has to take her time to say goodbye. That's our slow step. Once she's finally said all of her goodbyes, kissed him 6 or 8 times, now we can move on. But until then, we're waiting on her. So in the same way, we're just waiting on this functional group to leave, to vamoose, to get the heck out of here. Once that happens, we can proceed. So, with all of that in mind, let's look at the mechanism for the E1 reaction. So, just like we did with the E2 reaction, let's look at the substitution version that's going to be occurring alongside this. In the SN1 mechanism, I'm going to have my chlorine as a leaving group leave, and then once that's already gone, the ammonia is going to be attacking the carbocation, where it will then become an amino group. However, N as an amino group with 3 hydrogens isn't stable, so in all likelihood, it would lose one of those hydrogens. That's a little bit of a side note there. Basically, that's our SN1 reaction. That's an additional final step that would also occur. Over here, I've got the substrate set up to go through the E1 reaction, and it's going to follow very similar steps. The first thing that's going to happen is this chlorine is going to leave. All right, in the next situation, all prepped up and ready to go, I've got this ammonia ready to do something. I've got a carbocation here and I've got a hydrogen here, but it doesn't really matter which branch the hydrogen is off of. Technically, the hydrogen could be here or here. All 3 would be options, and we would get 3 different alkenes as a result. But we're only going to do this once. We're not going to go through and be as in-depth as we possibly could. So our ammonia here is going to turn into an amino group. Our ammonia, well, it's not in this case. Our ammonia is going to attack our hydrogen here. And as it does, that hydrogen is going to lose its bond to that carbon. So now, this positive charge is going to bond with that carbon's extra bond. In our final product, we have an alkene along with an ammonium cation and a chloride anion. So all throughout this reaction, we end up with 3 different products. First, we get our amino group that is attached to our alkane. Then we get an alkene with a double bond in it. And then we get a bunch of ammonium, which is going to bond with this chlorine. So we end up with ammonium chloride as our salt. So we can see we end up with quite a few different products when we have these reactions and these mechanisms mixing. If I was trying to get the amino group, I would need to figure out a way to get rid of this alkene and get rid of this ammonium chloride in my solution. So we ended up with SN1 products, E1 products, and a salt.